So first of all, outline of this presentation. In this presentation, basically we are going to discuss logic gates first, how we can make different logic gates with the help of these basic instructions. Yesterday we discussed three basic instructions. First one was XIC, examine if closed, that is also known as normally open instruction. Then we discussed XIO, examine if open, that is also known as a normally closed instruction. Then the third one was OTE, output energize. So with the help of these three instructions, today we are going to make basic logic gates, and we will just check the working of all the gates with the help of LADSIM software as well as with the help of RS Logic software. So after these logic gates, I will tell you the concept of latching and unlatching, what is latching and what is unlatching. Then we will discuss the concept of software relays. What are these software relays in case of your PLC programming. Then what is the purpose of master control relay in programming? After discussing all these, you can say instructions, basic instruction, then we will do programming using these instruction in LADSIM, and we will perform this same programming in RS Logics also. So I am going to give you the exposure about both the softwares, means how these two softwares can be used for programming using these instructions. Then we are going to conclude. So first of all, logic gates. So we are going to use these three instructions, XIC, XIO, and OTE, to make these different logic gates. First of all, we will discuss NOT gate, AND gate, OR gate, and XOR gate. So these four basic gates we are going to make with the help of these instructions. So first is NOT gate. So here you can see that in NOT gate, we are using one XIO instruction as input and simple OTE instruction as output. And if you remember, we have already discussed the working of this, you can say, ladder diagram yesterday when we were basically discussing the working of normally closed input. So it is same. So NOT gate means we are using one XIO. XIO is your NC instruction. Here you can see that this XIO, and we are using one OTE. So NOT gate means whatever is your input, the output will be basically complement of it, right? So here you can see that yesterday also we discussed this. Initially, when we are not giving anything to this input, let us take that same example of switch and fan. Let us say that switch is off. We are not giving any input to this switch. In that case, our this path is complete. This is complete, and our fan will be on. When we make this switch on, means 1. At that time, this path will be open, and so that this circuit is not complete. And when this path is open from here, it means that now your fan is off. Off means 0. So this is your working of NOT gate. Yesterday also we discussed this thing. So here, if we just take it in technical terms, we can say that XIO instruction with OTE instruction will make a NOT gate. If input I1, so we have to give basically address to these inputs. Let us say address of this input is I1. This is I1 is low, first condition. Then output O1, we are giving address to this output as O1. So when input I1 is low, then output O1 will be high. You can see that high means 1. And when input I1 is high, means 1, at that time your output O1 will be low. So here you can see that whatever is your input and output is complement of this. So this is your NOT gate. Next is our AND gate. Here you can see that AND gate is nothing but it is basically using two XIC instructions in series. Here you can see that I1, I2, they are in series with each other. And we are using these two instructions with output O1, which is OTE instruction. Now we are going to verify the working of this ladder diagram. When I1 is 0 and I2 is 0, means both are 0. If you remember, I told you in XI instruction, uh, if it is 0, then it will act as what? It will act as open. So it means that input 1 is 0, input 2 is 0. It means your circuit is not complete from here as well as from here. So that is why your output will be off. So here you can see that our output is off, 0. When I make I1 0, I2 1, right? In that case, our circuit is complete here, right? Because I2 is 1, but our circuit is not complete from I1 because I1 is 0. Circuit is still open here. So that is why our path is not complete from here. So that if path is not complete, then output will be low or off. So here you can see that output is 0. Next condition is when I1 is 1, I1 is 1 means now circuit is complete from here, and I2 is 0. When it is 0, it means now circuit is not complete. It is open from here. So in this case, your circuit is complete up to this point. Now it is open here, and now it means that your circuit is not complete and our output will be again low in third condition also. In last condition, we are keeping this I1 as 1, right? I1 1 means when it is 1, this circuit will be complete. And when this is also 1, then this is also complete. So when both the inputs are 1, then your circuit will be complete, and in that case your output will be 1. So here you can see that your output is 1 in this case. So this is the working of AND gate. Basically you have to check if circuit is complete, only then your output will be high, otherwise your output will remain low. So here you can see that if both inputs I1, I2 are high, we are talking about this term, this condition. If both inputs I1 and I2 are high, only then our O1 will be high. Otherwise, it will remain low in other three conditions. So that is basically now, this is the function of this AND gate. Now, next is our OR gate. And now how to make this OR gate? In case of this gate, basically we have to use two XIC instructions, I1 and I2, in parallel with output instruction O1, and it is going to make your OR gate. So here you can see that I1, this is, and I2. These two instructions are parallel with each other. In earlier condition, these were in series. Now these are in parallel, and we are using these two instructions with OTE, right? So now let us verify the working of this OR gate. Initially, your I1 is 0, I2 is 0. Means this is 0, this is 0. It means circuit is not complete from here. And circuit is also not complete from these. There are two paths. One, this is the first path, and this is the second path. When both are 0, circuit is not complete from both the parts. It is open from both paths. So that is why your output is 0. Now next condition is 0 and 1. Means I1 is 0, I2 is 1. It means this path will remain open here because I1 is 0. And this path will be closed because I2 is 1. So our circuit is complete from second path here. Like from here, this is complete. And in that case, our output will be high, energized. So it is 1. Then next condition is when I1 is 1, now your this is 1, this is 0. This one means now circuit is complete from here, your path is complete, this one, but your this path is not complete. But still your path is complete from two different you can say circuits. So now it is complete here. In that case also you will get your output high, your output will be on. And the third case, last case is here when both the inputs are 1 1. When I1 is 1, I2 is 1, both the inputs are 1 1. In that case your circuit is complete from here, circuit is complete from here also. So both the paths are basically complete, so again you will get your output high. Here you can see that. So this is the basically working of OR gate. So here we can say that if any one or both the inputs I1 and I2 are high, any one out of these two or both, if these two inputs are high, only then your output 1 will be high, otherwise it will remain low. This is the working of your OR gate. Then fourth one is your XOR gate. Now in case of XOR gate, you will see one XIC input I1, this one, and one XIO input I2, XIC and XIO. These two inputs in parallel with one XIO instruction and one XIC instruction, and these are basically connected with your output, and this makes your XOR gate. Now let us see the working of these this XOR gate. Initially, when your input I1 and I2 are 0 and 0, right? In that case, uh, let us consider the first path. I1 is 0, I2 is 0, right? When uh, these two are 0, it means that our this again there are two paths. This is the first path, this is the second path. First we are analyzing the first path. So when it is 0, it means it will remain open, and our circuit will not be complete from this path, right? It is closed here but still open here, so circuit is not complete, this circuit is not complete. Second, now this is 0, this is 0 means this will remain open. So our second path is also not complete because it is open here. So when both the paths are not complete, it means that your output will be off, low. So here you can see that output is low. Now second condition is 0 and 1. 0 and 1 means in first path XIC is 0, XIC is 0 and XIO 1, right? So if I make this one I2, so in this case this is 0 means it is open, and this one is 1, it will again open. So both the means points, these points are open, so circuit is not complete or path is not complete here. Just consider here, when XIO is 0, 0 means it is connected, XIC is 1, 1 means now this is also connected. So in this second condition, our second path will be complete and our output will be high. So here you can see that our output is on, right? Then next condition is input 1 is 1, input 2 is 0, input 1 is 1 means this is 1. When it is 1, then it will act as connected, a path is complete. Then this is 0 means it will act as NC, right? So in that case, this path is complete, right? So our output is again 1. In case of second, if it is 1, then it will act as open. If it is 0, it will remain open. Then this path is not complete. It means that in this condition, our this path is complete. Because of that, we will get this output as 1, right? Then the next is here when both the inputs are 1 1. When both the inputs are 1 1, in that case basically you will see, if it is 1, no doubt it is complete. But this is also 1. When this is high, it will make this circuit open. And here again it is 1, it will make open here. So these two will be open here in condition, or in this condition. So both the paths are not complete. So that is why again we are getting this output as low. Our output is off. So basically this is the working of our XOR gate. Now how to basically check the working of these gates? I will just show you the. Now you will see the working of these gates. Now first of all we are going to check it in lead sim. In lead sim, here so how to basically use lead sim? First of all, just look at this. As I told you, it will work for 20 minutes. This is the lead sim software, and we are going to check how it works. First of all, you should be aware about the working of this software. So now same basically ladder diagram we have to create here. You can see that we have here xic instruction. This is xic. Take xic instruction, give address, input address. Let us say it is input 1. Then take one. In case of branch, you can create branch in this way. You can take one more xic instruction. Basically we are making what? We are making OR gate. We are taking another input 1 and 2, and now you have to take one output energize instruction, OTE. Take output OP0. So let us say your OR gate. Now OR gate is complete. Now go to run mode from here. Run mode, and now we have to make this on off transition. Initially both the inputs are 0 0, so your output is 0, right? These are open. Now make 1. So you are making it 1, your output is high. Here you can see that it is now on. You will make this high, again your output is high, right? And if when you make both the inputs high, again your output will be high. So OP0, you can see it is on, red. So in this way we can check the working of this OR gate. So you can see that it is very simple. You can easily use these ladder diagrams, and you can make the programming, and you can make OR gate with the help of this. Now I will show you the working of other gates. we have to go for lead sim. So here you can see that this is lead sim. Now we are opening it. Okay. Now first of all we will check the NOT gate, right? So for that, for NOT gate we have to take one NC instruction. Here you can see that it is written over there normally closed, or we also call it as XIO, examine if open. Take this instruction, place it here, and give address, input address. Let us say we are giving input address as IP1. Click OK. So this instruction is there. Now straight away we are taking one output OTE at the output, and we can give address OP1 to this instruction and OK. Now you will see that when we are going to enter here, IP1 is open. Here you can see that it is off right now. So whenever we are going from this edit mode to run mode, you will see that without giving anything, means when your input is off, your output should be on. So here you can see that here. Now input is low, output is high. Or we can say that input is off, output is on. So when I will make this on, then your output will be off. So your output IP1 is off. So here you can see that it is just, it is working like your NOT gate, right? So in this way we can make NOT gate. Now we can also go for AND gate straight away from here. First of all, we can go to edit mode. For AND gate, we need two XIC instructions in series with OTE instruction. So take first instruction, give address IP. This one, give address IP0. Okay. Take another XIC instruction, place it here in series, give it address as IP1. So both the inputs should have different address here. So we are giving here IP0 and IP1 address to these two inputs. Now we have to place one OTE instruction in parallel of this. Select this OTE, place it here, and give any output. Let us say OP0 we are giving. Okay. So now our AND gate is complete. Now we have to check the working of this AND gate. In that case, just go to run mode. So when we go to run mode, you can say run mode means this will be red. You are in run mode at that time. So initially both the inputs are low. You can see that this is low, this is low. That is why our output is also low. So it is open from here, it is open from here, and output is low. Now I will make one input as high. Let us say I make 0, this is 0, and this is 1. Make it 1. So when I make it 1, you can see that this red color, you can notice. Red color means now it is complete here, but still your path is open here, right? So your path is open here. So that is why this path is not complete and your output is still low. Our next condition is I will make this one and this is 1 and this one is 0. Make this one 1. So here you can see that now this instruction is closed, but still this instruction is open because it is 0. That is why again your path is not complete and our output is low in this case also, right? So now what is the next condition? Next condition is our 1 1. Make both the inputs 1 1. Input IP0, IP1, 1, right? Now in that case, you can see that your this instruction is also closed, this instruction is also closed, and your path is complete and your output is high. Here you can see that. So I think now it is clear to everyone. You can easily work on this software and it is very user friendly. And now we can go for another XOR gate instruction. Delete this one. And then take one XIO, it is IP0. take one XIC and XIO instruction. Let us take it as IP1. Okay. Now we need run this. We need one loop. So you can see that how to make this basically parallel connection. Is it okay? Yes. Now I will take one XIC instruction, and give address as IP0. Okay. And another one is XIO instruction and address is IP1. And we have to take one OTE instruction here at the output. And you can give address as OP0. So now our XOR gate is complete. So in that case, basically we have to again go to run mode. So when first condition is 0, 0, 0, 0 means red color path is complete here because it is NC instruction, but it is open here because this is 0, this is also 0. That is why this path is also not complete, this path is also not complete, and our output is 0. Then we will go for 0, 1, make it 1. Now you can see that this is 0, it will act as NC only, and it is 1. Now after making this 1, this is complete, this one, and our output is high, OP0, right? And a second condition is now I will make it 1, 0, 1, 0. Now you can see that this path is complete because this is 1, this is 0, and our this path is complete and our output is high. Right. Another condition is both the inputs are 1, 1. When I make both the inputs 1, 1, in that case, our path will be open from here and here where there is NC connection, and our both the paths are not complete. That is why our output is low. So in this way, you can see that how you can make your programs and how you can check the working of these programs. So in this way, we can work in LADSIM software. I think now it is clear to everyone how to work with LADSIM, and all of you can easily make these gates using the LADSIM. And I hope everyone has already downloaded this LADSIM and it is already loaded on your PC so that we can have practice in the afternoon session on the same. Now, this was the basically exposure of LADSIM. Now I will give you exposure about your this RS Logic software. So first of all, RS Logic download was discussed yesterday. Now I will just show you the basically setup of RS Logics, how to do the setup. This setup is also very important because it is not that much easy, just like your this one, you can say LADSIM, because in this we have three softwares: RS Logics Starter, RS Logics Link, RS Links, and then RS Logics Emulator. So these softwares we have to basically load on our PC. Yesterday we have seen how to download these softwares. Now we will see how to basically load these softwares on your PC. So I am just showing the uh, demo how these can be. So here you can see that we have different softwares, downloaded softwares here. Three softwares are there. You can say zip files, micro light, RS links. So we have to basically start with these three files. First, we are going with micro light. First of all, we are unzipping it. You have to unzip this one. Go to the setup. So here you can see that we are in setup of RS Logix Micro. Accept the license. Here you can give the name. It is user defined. You can give any name. So I am just writing here Mehra, and here you can give your institute name maybe. So here I am just typing NITTTR. Next. So we will go with the complete installation and start install. So files are being copied on your PC. Is it visible to everyone? Am I audible? Screen is visible. Anyone from
Yes,
the
visual,
participants?
visual, sir.
Yes, sir, it's
Visual.
visible.
Right, right.
It's visual.
So just we are going ahead with this installation. So finish. Now you will see the window of this one on your desktop. Now we are going for the second installation, second software, and this software is your RS Links that contains RS Logix Emulate. Again, you can give your name. Again, we can select complete and install. So finish. So our two softwares are installed, Emulate and Micrologix Lite. This is the third one. This is RS links. Actually, RS links is basically heavy software. It takes time for installation. Just I will show you the initial steps, and then we will close it down because it will take some time. Then we will go ahead with the working of this RS softwares, Rockwell software. These steps are same for all the three softwares. You can give any name and you can give your organization name. You can see that it is very. So I am just making it fast so that you can view. Just I am forwarding it because it is of very means you can say half an hour installation. So we are not going to waste time. Just I am showing you the different steps, what is happening for installation of this software RS Links, because it contains all the drivers for communication between different PLCs of Allen Bradley and your PC, right? So now here it is complete. Here you can see that now finish. So you can finish it and then it is over. After this one, you can see after installing all these three softwares, you will see Rockwell software, this tab in your startup this window, and you will see all the softwares, RS Logix Micro, RS Logix, this Emulate and RS Links. These we have basically installed on our PC. You will see all these softwares on your PC, and you can place them on your this also. I can show you. Here you can see two windows, RS Logix Micro and RS Emulate, and RS Links is just below that. So in this way you can install here. Now you can see this one. After installation, you will get these software: RS Logix Micro Starter, RS Logix Emulate, and then RS Links Classic. So these softwares will be there on your PC. So now we can go ahead with the working, how this RS Rockwell software it will work. So for that we can again go to the RS Logix working. Just here I will show you how it works. Now, first of all, we are going to select the RS links. Here, basically, we have to communication. We have to configure the drivers under RS links, right? So under RS links, you can see the long list of PLCs. So we have to select a particular PLC or communication devices. So we are here using SLC 500 emulate driver. Add new. Okay, station number is 00. Okay, so you can see that now it is added on our screen. So first is we have to configure the driver in RS links. So it should be here on your window. Then you can close it. You can down this window. Now start the RS logics for editing your program. So this is RS logics micro. Select this is the PLCs. We are selecting micrologics 1000 PLC for programming. So you will get this window here again. Now you can go for your ladder diagrams, but slight difference is there as compared to LADSIM. This is the first rung. We always call them as rung in ladder diagram. Select XIC instruction. This is XIC instruction. Here you have to give address. Addressing will be different. You have to type the address. I colon 0 is the station number by 1. I is for input, 0 is for station where PLC installed, 1 is the number of input. Then likewise O colon 0 by 1. Simple, we are making this program and we will just check the working of this. Before that, now you have to basically check the errors. Verify project and you will see error. Some error is there. What is that error? Just check. Rung 0 error invalid file type. Here you can see that. Basically, we have to type here I, but by mistake we have typed here as 1. So make it I. First one. I colon 0 by 1. Now again verify. Verify the project. Now you can see that verify has completed, no errors found. Now your program is okay. Once it is okay, and then you have to save it. Save the program. You can save it in any folder on your PC with any name. This is user defined. I am creating new folder here. Let us say it is name of this folder is RS Logics Working or RS Logic Project. I have given it name as STC demo 1. Now it is saved. Now our next task is we have to go for emulation. We have to check its simulation and it will be done with the help of this emulator. Open, go to that path where you have stored the program. This ladder diagram, you have to go to that path, Rockwell projects, and here you can see that STC demo 1, open, select it. Okay. Now you can see your STC demo 1 is here on the upper window. Again, go to logics. Here, go to communication. Then under system configuration, you can see that you have to select the workstation. It is 1000. Once it is selected, you will see now it is ready to run. That now it is rotating. It means that you are ready to run your program. Go to run mode. Yes, from remote. Now when you are in run mode, then these two bars will be green. You can see. Now make this input 1, toggle bit. So when you make it 1, your output is high. Here you can see that. It green means it is high, and if it is there is no color, then it is low. When you are going to make it off, then again it is off. So in this way you can make it on and off. So in this way these three softwares work together in order to simulate your program, right? This was the demo of working of RS logics. Now how to create logic gates in case of this RS logic software. So similar to LADSIM, just the addressing will be different. Again, go to communication drivers, select SLC 500 emulator, add. These steps are similar. Whatever I have shown you in working, you have to just repeat these steps, nothing else. Now close. Now go to micrologics. New project. Select micrologics 1000. Okay. Now watch how to create those logic gates with the help of this micrologics. And here we are creating XOR gate. So once your XOR gate is complete, you have to go to emulate, select that gate, and station is 1. Okay. It is basically repeat. These steps are already explaining the working. Now you can again see that logo is rotating. Go to run mode. Yes. So now you can see the green lines. So you are in run mode. Make the transition of inputs from 0 to 1. So now path is complete, below 1 and your output is high. And when we make both 1 1, again your output is low. This is the last condition. So in this way, basically we can make these logic gates with the help of you can say XIC and XIO instructions. Now, I think these logic gates are clear to all of you. Now we will go for latching and unlatching. What is this latching and unlatching? I will discuss this. Uh, Actually, these two instructions are used in basically pair. Just a minute. So first of all, what is the purpose of latching and unlatching? Actually, I will give one example. Uh, Yesterday, I just told you that input can be a push button or it can be toggle switch. So first, in order to understand these two instructions, latch, unlatch, basically we have to see the difference between push button and toggle switch. Push button is basically just like your on-off switch on your maybe PC or somewhere else. Push button means when you press it, at that time it will be high, and when you release it, it will be off. Right? So it will you have to continuously press it to make it on or high. So when you press it, it will be high, and when you release it, it will be off. So in order to make any output permanently high, you have to make that push button pressed. Only then that output will be high. But in case of toggle switch is just like your normal switch at home. We use for lights, we use for fan. When we press it, it will be on and it will remain in that position, right? So you need not to press it continuously in order to make it on. Once you press, it will be on, and when you again basically make it off, it will remain off in that state. But in case of push button, it will be on when it is pressed, and whenever it is released, it will be off, right? So latch and unlatch instructions are used with push buttons to make them continuously on after pressing once. So when you press it and you release, right? After pressing it for a moment, and when you release that push button, your output connected to that push button should be high, right? It means you are latching that output is latched. And when again next time you press it and release, in that case your output should be off. Means same push button we are using to make something on and something off, but we are not continuously pressing it. So we can say that this latch and unlatch instruction, it is used with push buttons to make that particular whatever output is connected with that push button, to make that particular output on continuously or to make that output off. So latching here means making that particular output on, unlatching here means making that output off. So you can say it is retentive output instructions. Output latch means retentive. When I latch some output, it will remain latched. It will remain on. In order to make that output off, I have to use another instruction that is unlatch. Then that output will be off. So that is why I told you in the beginning, this these two instructions always work in pair with each other, right? So here you can see that OTL, and how we denote this instruction. This instruction is denoted by OTL, output latch, and OTU is output unlatch. So here you can see that OTL can only turn on a bit. Just forget it bit. Actually, this bit is related with the microprocessor term. You can say OTL can turn on an output, and OTU can be used to turn off that particular output. So basically, these two instructions are used in pair, and these are used with you can say same address, same output address will be used to latch and unlatch. In this way, these instructions are basically used. Then these instructions are usually used, already told, in pair, right? With both instruction, this is also explained, with both instructions addressing the same bit. So these two instructions are used in pair, and both the instructions will have same address for latching and unlatching. Now, first of all, we are going to discuss this OTL instruction, output latch. In OTL, when we assign an address to the OTL instruction, that corresponds to the address of a physical output. Physical output can be anything. It can be conveyor, it can be lamp, it can be hooter, it can be valve, it can be motor, anything. So basically, we have to attach some address of physical output. And then that output device wired to this terminal is energized when this bit is set. When input is high, then that will remain high until we use OTE instruction to make that off. So when run conditions become false after being true, means push button, when you press it, it will be high, and when you release, it will be low. When you press, it is true. When you relieve that button, it is false. So what we are saying, when you press the push button and release it, in that case, your output will be set. Your output will be on, right? And that output will remain on until we use another instruction in another rung with same address, that is of OTU. Now, OTU, when you assign an address to the OTU instruction, right, that corresponds to a physical output. The output device wired to this, you can say, instruction will be de-energized or will be off when we make this instruction true to false. The unlatch instruction tells the controller or processor to turn off the address bit or output. Thereafter, that output will remain off regardless of the run condition, whether that push button is uh, on or it is off. Regardless of this, that instruction will remain off, and it will be again on only by using OTL instruction in another rung. Only OTL instruction can make it on, and only OTU instruction can make it off. So that is why these two instructions work in basically pair. So just I will give idea about these two instructions on software. Then we will wind up this session here, and we will continue with the session after lunch. Uh, and after that, we will go for practice session. So here, now first of all, I will give you exposure of these two instructions in LADSIM. In LADSIM, we'll see how these two instructions are going to work. So here you can see that two instructions, latch and unlatch. After the first we are using one XIC with input 0. Now use, this is latch denoted by L, and we are using output 0. Add another rung. Again take XIC instruction, make it I1, another input we need, and same output address we have to use to make this output off by using U instruction, unlatch instruction. Now go to run mode, press. Now press and release. Now you can see that after pressing and releasing, your output is still on. If you want to make it on, use another switch. It will remain on. Now if you want to make, you have to unlatch here. So this is for latching and this is for unlatching, these two different instructions. So in this way, basically, we can use this latching and unlatching. Then how this instruction is going to work in RS logics. So we will just watch how we can use this latching and unlatching in RH. Same steps, configuration of your drivers. So give input address I colon 0 by 1, take output, O colon 0 by 1, Here take another address I colon 0 by 2, and output will remain same. So first is latch instruction, second is unlatch we are using. So here are the icons for this latch and unlatch. Now verify the project, save the project. Save it with any name. Let us say latching 1. Now go to emulate. Here another method is there, straight away we can download it. So here you can see that instead of going to emulate, straight away download it. Now here that icon is rotating, and from here you can go to run mode. So you are in run mode. Now I will make it on and then off. Once it is off, even then your output will be on. Now you can see the output, it is still on. Now in order to make it off, go to the second one, make it on and off. You can see that it is unlatched once it is made high. If you make it low, then it will remain off. If you want to make this output again on, again you have to make high to low transition here in this. So this is the working of latching, unlatching. And latching, unlatching, as I told you, it will be used with your push buttons only.